We're very pleased to present Joe Horn, our engineering manager, and do a real-time assembly components, RVAT assembly for you.
We will demonstrate the assembly of this structure here, and my colleague Steve will bring up the software so we can watch the interface and see how everything is integrated nicely in software.
Okay, so in our RVAT software, what we're seeing here is a live view of the camera, and we can see our components on the table. What we also see right here is the representation of the CAD model. So this will be the as-built condition that we need to build our component to. So I am going to launch the RVAT software. And what the RVAT software does is it automatically brings the important information to the user. So it automatically rotates the view, opens the parts that are critical and the critical dimensions that we need while building the parts. In our interface, we have drop-down menus for all of the steps to build the parts, and in each step, there's associated steps underneath it. We also have written guided instructions for the user that can be input. Under build comments, if there's any issues that happen during the build, the technician can type in a note here. They can also take a screenshot and capture what's actually happening with the live view. And down here, we have options of turning on the color mesh mapping. So what the color mesh is, it's actually looking at the position of the part. So we're looking, when we go to the live view, this will be the true position of the part while we're moving it into place. Down in reference components, we can choose what we want to use as our reference. We can choose the CAD to be the reference or any other part in our assembly. So for this demo, I'm going to choose the CAD as the reference. And then at the bottom, we have a couple of buttons. So we can do a tool tracking of smart tools. And the next button is assembling parts. So for this task, we're going to click on Assemble. And right now we're running live. And as Joe rotates the part, we can see the live position of the part moving in to the correct spot. So everything in green is plus or minus 30,000ths of an inch. And then I also called out a specific angle of that bracket that's a critical angle on the drawing. And now that we have it in position, we can stop the tracking, and that's done. So very quickly, we rotated the part into position. We checked the total position and also the critical angle. So next, we can click on our next tag button. This is automatically going to move to the next part for the operation. I'll go ahead and turn on our mesh tracking again and click Assemble. So this is very, very easy, very quick, and very intuitive for the user to look at the live image while he's rotating the part into position. And that looks like a good spot there. So that's our second spot put into place. Now we'll move to our third part. So our third part here is a composite panel that's sitting on top of our linkages. And for this one, the full displacement isn't critical. We have two critical dimensions that need to be hit. So I'm showing the nominal position, which is the CAD, then the true position of where the part is, and the deviation live. So we'll start this, and Joe will put the part on and track these two critical positions into place. So what's important when we're looking at these values, I typically will look at one direction, the X or Y, and get one of them close, and then adjust the next value. So what's important is in these steps, regardless of if the part comes into tolerance or not, we're documenting the true position of where that part was put. After the fact, this can be bought off by quality assurance, but at least we have the check of where this part really was placed in the assembly. So if we have problems later on in the build, we can show where this part was put and document its true location.
You might want to talk to engineering about the design of this one.
So let's go ahead and say this is where this part had to go. It has an interference problem. So what we do is we stop the tracking, and then in our build comments here, we type in, there was a problem with fitment, and then just document that in the build comments. And now we can pass this along to quality or to engineering, so they can review this with the real data and looking at where the part actually went. So next we're going to do some smart tool tracking. So what Joe's holding in his hand, this is a click bond, and there's a click bond adapter that's snapped on top of it. So we're using that constellation of points to track where that click bond goes in space. The way we do that, we start our tool tracking, and it automatically detects the smart tool, and then Joe can start putting it into position. So typically this would be hand laid out with measuring tapes, but here we can track it into position really quickly. Now Joe can pull that off and put the next click bond attached to it, and we can move on to our next step. So down here we have a list of steps that we're going to go through. So we click on our next adapter, and it automatically switches to our next click bond. So we'll hit tool tracking, and now we can see the live position of where that click bond is going in space again. It looks like the Y is looking pretty good. Just need to readjust the X again. And there we go. And all these tolerances can be entered in for each value from your drawing, and you can modify them whenever you'd like. So the next operation is going to be a drilling operation. So click the next button, and it says drill point 1, and our instructions say use the drill adapter to drill pilot into the panel. So we'll hit tool tracking, and it'll start tracking our drill. And any of these adapters, these are built in the software. So if you have other tools that you use commonly, then we can turn your tools into smart tools by putting a few dots on your tool, and then programming them into the software. So after your drill bar is put into place, then we'll drill the hole, and we've documented where that hole was drilled. Looks good. So all of these steps are being saved in the background automatically. And what we also can do is put in keywords. So for projects, we can enter in the inspector, the date, the assembly location, company, department, project. And this field can be completely modified to whatever parameters you have, project numbers, part numbers, things like that. And this is all saved automatically also. Also in the RVAT software, we have a full file management system that allows us to look at multiple projects and search by inspector or by date, location, department, project, and it'll only show up the projects that has that inspector did. And then inside of that project, we have multiple parts that are associated with that project that we can look into and then open up automatically. So from here, this project would be done. We'll click exit, and then we see this pop-up, and it says we have this is our project validation. It says the following elements were missing. So there's a couple of extra parts that need to go in that we didn't put in for this demo. So we can click ignore. But that's a check that'll pop up every time if any steps were missed. So it automatically will check your project for you. And then from here, in the background, a report has been automatically generated of all of our steps. So this is our title page showing our assembly. This shows our base linkage with our check, and then our next small linkage, the panel position, the 2 click bonds and the drilled point. And then at the bottom, we get a full quality check of the entire project automatically. So while you're building your project, the quality checks are being done automatically, so you get your quality check for free. So that was a quick demo of the RVAT software. We can open it up for questions. And this is just the as-built.
Well, thank you very much, Steve and Joe. Really great demonstration of numerous capabilities of how RVAT is used in production, and how it captures the quality information and stores it to the digital twin. And you can see the image of the sensor itself and how we're able to use the sensor that was doing the measurements during that assembly. Well, anyway, thank you all very much for attending, and we're very pleased to be able to provide this technology in a really great way, and really helping the companies that are working with it in making their operations more efficient and making better products. Thank you all very much.